Okay, all right. Thank you, everybody, to be here tonight for this webinar. One of the long series of webinars that we have this year, and we decide to run this webinar to inform the community about what the SCAR Geoscience does, what's the action and expert groups, and how they work, and how scientists and students and all kind of interest people can actually be involved and contribute to these groups. So just to give you an overview about what SCAR is, in case you don't know it yet, SCAR is the Scientific Committee for Antarctic Research. It's a thematic organization of the International Science Council, and it's in charge with initiating and developing and coordinating high-quality international scientific research in the Antarctic region and in the Southern Ocean. And in addition to coordinating the network of thousands of scientists all over the world, with all the only scientific target to run science and to make progress in Antarctica. SCAR also provides objective and independent scientific advice to the Antarctic Treaty for their consultative meetings, and also provide information about science and conservation for the management of Antarctica and the Southern Ocean. How it does this through events, through white papers, through important papers, and for example, SCAR organized the Open Science Conference every 2 years, in addition with the meeting of delegates. Provide fellowships and awards for senior and young scientists to visit other countries, other laboratories, to increase their network, and also provide advice for data library, data banks, for policy and governance in general. The scientific component of SCAR, of course, is the most important activity. Is subdivided in disciplines, in geoscience, life science, and physical science. And it comprises action expert groups and also scientific programs. The SCAR is led by a committee, an executive committee, which is composed by the president, Gary Wilson from New Zealand, and 4 vice presidents, which are now Carlotta Escuzia from Spain, Professor Takumi Nakamura from Japan, Marcelo Leppe from Chile, and Burcu Ozoi from Turkey. And then we have the executive director, which is Chandrika Nath. I can use my pointer, so pointer Chandrika here, and supported by the secretariat, Owen Griffin, Joanna Grabov, and Agar Dons, and Agnes Ganishut. The president and the vice presidents are in charge for 4 years. They are elected by the SCAR delegates. The geoscience group is led by Jesus Galindo from Spain, Zaldivar from Spain, Naresh Pant from India, myself from Italy, and we have the support of Matilde Ferrante from OGS from Italy, with the SCAR Fellowship. This is the list of the action expert group, subdivided by geoscience, life science, and physical science, the 3 main pillars of SCAR. Then there are other groups like standing committees in charge with, for example, the connection with the Antarctic Treaty, the geographic information. We have the finance and human and social sciences. And also we have action and expert group, which are cross-disciplinary. They work across physical lives and geoscience. And then we have main research programs and other groups co-sponsored by other programs outside SCAR. So in particular, geoscience is aimed to collect geological data, like for example the ADMAP group, collect digital magnetic anomaly data from different acquired by different countries to produce maps like this. IPSCO, the International Bathymetric Chart of the Southern Ocean, is another group which is collecting bathymetric data and provide bathymetric maps. Then we have groups like the Antarctic Volcanism that is identifying volcanic bodies and provinces and map them and provide some catalogs and other products. Then there are action group like RINGS, which is cross-disciplinary. And in this case, for example, the target is to explore, to investigate the rings of Antarctica, which are the grounding zone where the ice start floating, using generally airborne geophysical data, but of course involving also oceanographic data acquisition and other data, because it's a really cross-disciplinary group. Today we will hear about the EG-GEOCON group, Geological Heritage and Geo-conservation, from Anne Grunoff, Cliff Atkins, and Florencia Milanese. So we welcome, we are very grateful to you to use your time tonight for informing us about what your group does and how the scientific community can be involved. What's the future, the target of your group? What's going on? What have you already achieved so far? And just a last slide to show you what's next. So we had a long list of webinars already run this year, and the next one will be on December the 3rd at 4 p.m. UTC. And it will be about the Antarctic Seismic Data Library System, which is not an action group, but it's a data library which is collecting seismic data used by the whole geophysical community. So I leave, that's my last slide, and I stop sharing, so you can start.
Okay. Thank you very much. I think I will share my screen now and get things rolling.
Yeah, just a second because I have to. Okay, done. Yes, thank you.
Okay, how does that look to you?
Yes, we can see it.
Okay, good. Well, welcome along, everyone. Good morning, good afternoon, good evening, wherever you are in the world. We're going to talk about the EG-GEOCON, Geological Heritage and Geo-conservation. We're going to do a bit of a tag team today with 3 speakers. I'll get things going. My name is Cliff Atkins. I'm from New Zealand. I'm the Deputy Chair. And then Anne will take over. She is the Chair from USA. And then Florencia, early career researcher from Argentina, will take over. I thought it would be useful to start with just a little bit of background about what geoheritage and geoconservation is. These terms get used quite a lot, and most of us have a general idea of what it is, but I find a lot of people struggle to articulate it beyond that. And in fact, I also struggled when I first got involved with this group. So our secretary and geoheritage expert, Enrique, has put together a couple of slides, and I'd like to spend a couple of minutes just talking our way through that. So the concept of the new geos, this concept that has come about in the last couple of decades, is useful. We're familiar with terms like biodiversity. We can simply replace bio with geo, and I think that gives us an understanding of what we're dealing with. So geodiversity is the non-biological processes and elements of our environment. So think of it as the geo equivalent of biodiversity. Similarly, geoheritage or geological heritage is the non-biological components of elements that we are interested in. Interested because it tells us something about the processes and about those geological components of the natural world. So those geoheritage elements that we give value to allow us to then assess a need for any geoconservation that's required, in the same way that we would catalogue, protect species, habitats, and ecosystems. And we can think in the same way about the geo environment. So this concept of geoconservation is really the tools of doing the conservation. So the strategies, the actions, the programs that we can put in place to protect and conserve our geological heritage, in the same way that we would do that for species, habitats, and ecosystem conservation. So that helped me understand what the geological heritage and geoconservation is about. And a couple of quick comments about what is heritage. Well, heritage, it's a bit of a subjective concept, but it's something where we assign value to an element. So an element defines what kind of heritage we're talking about. It can be about things, tangible things, or intangible things, knowledge and ideas. It can be about objects or sites. So we might give heritage value to the Mona Lisa, for example. We understand that there is a lot of history there. It's a world famous piece of art. We might give heritage value to the KPG boundary, which we have done, in fact, and that's illustrated in the picture there. So we can assign heritage in a number of ways to a number of different things or ideas. It is subjective. It's something we can ask questions about. We can semi-quantify this, which requires expertise of people that know something about those elements. So that leads us on to the fundamental concepts behind geological heritage. We assign value to geological sites and geological processes and things that allow us to identify and interpret that geology. It tells us something about the processes. It tells us something about the history of the Earth. And a term Enrique uses, which really resonated with me, it's the memory of the Earth. It allows us to understand it. And that's why we give these elements value or geoheritage. And the importance of exposure should be highlighted here. The elements that we're talking about can be observed and understood. In geology, most of the elements we're talking about are non-renewable on a human timescale. Many of these things have taken millions of years to form or are millions of years old. And while they are being created and formed and destroyed through time, on any reasonable human timescale, they are not renewable. So that is another reason that they have value or geoheritage value. Once these things are gone, they are effectively gone for good. That, of course, leads us into this idea of geoconservation. So as I said, that's the mechanisms that we can put in place to recognize if there is any vulnerability and a need to preserve or conserve these. As we all know, there is increased tourism, there is increased scientific sampling and infrastructure development, new bases happening in many places in Antarctica. So we need to front foot this and be aware of where those pressure points are, and are there geoheritage sites that require some geoconservation. So although our group is about identifying these sites that have heritage value, there may be some sites that do require some geoconservation effort. And I'll make the point here that out of the 72 current ASPAs, the Antarctic Specially Protected Areas, only 7% of those were designated primarily on their geological criteria. Most of them are based on biological criteria. So there is an opportunity and a need here to recognise sites with geoheritage value and identify any sites that may require some geoconservation effort. Which leads us on to the objectives of our group. And I realise there's a lot of writing here, but it's worth going through these things point by point. We're about trying to formally identify those places that do have geoheritage value. We call these geosites. They have outstanding aesthetic, intrinsic, scientific, or educational value, and they're telling us something about the geological evolution of Antarctica. So that's geoheritage value. We can develop a register of these sites that represents different parts of the geological story of Antarctica. Once we have that register, that list, that allows us to identify any need for conservation effort. So part of our role is to prepare documents, products that facilitate SCAR's role in providing advice to the CEP on geoconservation and geological heritage issues. So we are the group of experts, the geo community, which can tell SCAR, yes, there are some sites that we should recognise, and some of these sites actually need a bit of protection effort, perhaps even developing them into future ASPAs. And we are also about promoting the dissemination of information about existing rock repositories and the use of those to reduce oversampling. So just stepping back into the background here, the action group on geological heritage and geoconservation developed this framework. And so there was wide consultation, and we came up with 9 different intervals. We call these geological frameworks. They are designed to capture the key parts of Antarctica through time in terms of its geological development. And so you can see here we've got things like Archean cratons, Proterozoic origins, Neoproterozoic and Paleozoic rifted margins, the KPG transition, Cenozoic glacial history. I won't read them all out. Some of them overlap both in time and in scope, but this was still, we decided, the best way to try and frame our efforts in recognizing geoheritage and applying geoconservation where it's needed. So these 9 frameworks were developed, and the very first geosite that was developed was the Cretaceous-Paleogene transition at Marambino, Seymour Island. And that was Geological Framework 5. That is also included in the first 100 of the IUGS Geological Heritage Sites. So in 2022, the action group became an expert group. We now have 35 members from 16 countries. We have a steering committee of 16 members from 9 of those countries. And that is a fluid and developing membership, and it can change through time as need be. The methodology that we follow is very closely tied to that of the IUGS. And as most of you know, there is great effort around the world to recognise places of geological heritage. So we are very much in step with how they do things. And the idea there is that any Antarctic sites are directly comparable. And in fact, we are in the process of identifying Antarctic geosites which can contribute to the IUGS global geosites. So the way this works is that geosites representative of those geological frameworks that I just talked about are proposed by individual scientists that have experience in those places in Antarctica. They are then evaluated by people in the expert group and they're selected. So things that we consider here are whether they are a unique or singular site. For example, does this geosite represent the only place in the world that a particular feature or process occurs? Or perhaps it's the best site. So it's not unique. These perhaps sites do occur in other places. KPG boundary is a good example, but if we have a particularly good, a best site, if you like, then that is reason to make it a geosite. First site is also part of the criteria. And for example, we have identified geosites with meteorites, and we picked a site where they had first been described in Antarctica. So there was a historical aspect to the selection. Other places may show a particular pattern or series, so a stratigraphic sequence, for example, that tells us about some environmental change that occurred at a particular time in Antarctica's evolution. We also consider whether those sites are vulnerable to human impact, and are they truly internationally significant? And this is an important point because it elevates it beyond just scientists wanting to propose their favorite outcrop that they have visited a few times. It actually has to reach that bar of international relevance before it can become an Antarctic geosite. So Antarctic geosites that we decide on don't actually have any legal status under the Antarctic Treaty System, but as I said before, if there is any particular vulnerability to human impacts from tourism, from oversampling, from development of new bases, for example, then we may actually push that forward to say this site does require some geoconservation. And so we would then recommend that to the Committee on Environmental Protection as a candidate for ASPA status in the future. And so I'll just finish here, and I won't read out all of this, but this is the stepwise procedure that we go through for identifying these sites. So just to reiterate the point, this isn't just a collection of some favorite sites that geoscientists have been to. There is actually a method behind this of reaching out to the community, asking experts to consider carefully what might make up a geosite within the context of those geological frameworks. They propose it, it is then evaluated, and then we can formally nominate that geosite, and if need be, advance that forward for some conservation status. And I'll leave it there and hand over to Anne. Thanks.
Hi, can you see my screen? Okay. So that was a great introduction, Cliff. Thank you. So when we got started in late 2022, we decided, with 9 frameworks, one of them having already been done with the KT boundary, we would just focus on 3 to get started and work through the process of how we were going to get these nominations. So we started with GF1, which is the Archean cratons, GF7, which is the meteorites and evidence of impacts, and then GF6, which is Cenozoic glacial history. Now, we knew GF6 was going to take a while because that's a really big topic, and we knew there were a lot of sites to be proposed there. So we're still working on that. But with GF1, we had 10 sites proposed, and 6 were supported as SCAR Geosites, and 1 was nominated for a IUGS Global Geoheritage Site. With meteorites, we had 3 actual nominations, and 1 was supported as a SCAR Geosite and also nominated for a global geoheritage site. And then Cenozoic 1, we are still taking new proposals for that, but we have 15 proposals at the moment that we're putting together and getting the expert group to evaluate. Let's see, there we go. So I'm just going to briefly walk through the the geosites that were nominated and approved by SCAR Geoscience. And there are three sets of sites that are from the Pritz Bay area and three that are from Enderby Land. So the first one, starting farthest back in time, is a Paleo-Archean ultramafic intrusion. And this site was proposed because of its unique magmatic structures, rhythmic layering, and it's one of the oldest layered igneous complexes. So all of these geosites that have been nominated and agreed upon with SCAR Geoscience are on the EG-GEOCON website under reports. So you can find the information about each one of these nominations. Another site that was approved was the Meso-Archean mafic intrusive of the Rower Islands and the Sherbinia layered complex. I don't know always pronouncing these names, so I hopefully am in the ballpark. But as another mafic layered igneous complex, and that is a bit younger in time. And the third one from over here in the Vestfold Hills, Rower Islands region is a Neo-Archean ultramafic magnesium metasediments. And so this one's kind of an interesting one because as opposed to the process of emplacement, it's actually more of a mineralogical site because of its magnesium, sapphirine, spinel, and stenite combinations in the rocks. And this is late Archean, so it's the youngest one from this region. Then we have three from Enderby Land, I guess Western Enderby Land. And the first one is the Eoarchean tonalite orthonise of Mount Sones. So this is dated at 3850, so it's really an old one. And so the expert group felt that this was a really unique site that should be considered. Our next one is a Neo-Archean ultra-high temperature metamorphic complex at Mount Reser-Larsen. It's again a unique site because of the ultra-high temperature metamorphism and deformation and the mineral assemblages. And the last of the Archean sites is the Neo-Archean beryllium pegmatites at Casey Bay. It's the world's only known occurrence of this kind of mineralization at high temperatures. And so this site has been nominated as an IUGS Global Geoheritage Site. And I believe it's been approved maybe by IUGS. I'm not certain on that. So then for meteorites, there were a few locations, the Yamato Mountains, the Nansen area, Belgica Mountains, and Sorvandane. The expert group felt that the best representation and also historical one would be the Yamato Mountains, where the first meteorites were found. So I seem to be missing a slide there. For the Cenozoic glacial history, we have 15 sites proposed so far. This, you can imagine, covers a really broad spectrum of topics: ice formation, climate change, past conditions, oldest ice. So we are still working on that one, and we should have something, I would imagine, this year, nominations and what we will propose to the SCAR Geoscience. And with that, I'm going to hand it over to Florencia.
You all see my screen?
Yes.
Yeah. Well,
Yes.
hi to everyone. I'm just closing the presentation, talking about a few things. Sorry, I don't know how to hide the. There were. So we want to mention that so far Anne and Cliff have talked about our advances, what we have done. So now I would like to share you what's next. We have done so far some advances on Archean cratons, Cenozoic glacial history, and sites with record of meteorites impacts. So what comes next? We will try to gather information on possible geosites that record the history of, in order of time from older to younger, the history of Gondwana amalgamation and breakup. So any section, any place that gathers information about, for example, early Paleozoic history, like the Ross orogeny on the Transantarctic Mountains, and the Pan-African, the Paleoproterozoic Pan-African orogeny. Some key places as the Kukri peneplain and that classic unconformity that it's overlaid by the beacon group. Every site that has evidence of paleoclimatic or important and valuable paleontological records of Paleozoic history of Antarctica, well, that's what we are looking for. And also magmatic evidences of the extension of Ferrar igneous province, the igneous province that kind of preclude or cause the breakup of Gondwana, Ferrar in the Cratonic Antarctica, but also Chonaichi in West Antarctica. And our framework, the other framework we will advance next will be framework 4. And this is about the history of the tectonically active Antarctica. It's the history of the West Antarctic Rift System and Antarctica subduction zone. For example, of the history of extensional basins as and Backar basins, as Larsen Basin, James Ross Basin. Also the opening of the Bransfield Strait and Scotiarc and all the volcanism, all the Cenozoic volcanism related to it. And also everything related to the separation of Antarctica and Patagonia, the opening of the dry passage and the development of the Scotiarc. And we also gathered information on the repositories of the world, as Cliff, I think Cliff mentioned, I don't know if Anne mentioned too, but one of the objectives of GEOCON is to avoid oversampling. So if we organize as best as we can, and we have and we can make an easy access through SCAR website, for example, to all repositories in the world that have either geological or paleontological samples from Antarctica, that would be very useful. Not only because it favors cooperation, also because avoids oversample sites that in Antarctica that could be vulnerable. And this is all about protecting the GR heritage. So far, we have 440,000 catalog samples from 16 countries, members of SCAR. We have samples from New Zealand, Australia, Japan, South Korea, Russia, China, Poland, Germany, Italy, United Kingdom, Norway, Sweden, Brazil, US, Chile, and Argentina. And now we soon will have available a table with all the information organized by country, people that collected it, paper in which that sample was used, was published, and the easiest way to contact the repository curator. I would also like to share a contribution of an early career researcher, member of GEOCON, Tamara Amano-Grasso. So what Tamara did, she made this small museum at Esperanza Base. Esperanza Base is an Argentinian base that that has families living there during the year. So it's a place with a lot of children, and it's also a very touristic place. People visit it very often. So the idea of having this museum that contains a collection of fossils is to give the people the opportunity to know about those fossils, to know about the geological history and their geological importance. In Hope Bay, what we have, it's a very particular fossil flora of mid-Jurassic age that was first described by Anderson. And all these fossils of flora, very diverse flora. Now there is a small collection with descriptions that are public. I mean, tourists or people from the base can visit it and learn about the importance of this fossiliferous site. And at last, I would like to invite you all to become involved with EG-GEOCON. We encourage particularly the participation of early career researchers. So if you are interested or you know about a place that could have potential for being a geosite or potential to be, considered by our group, just contact with the leadership team. And we also have some travel awards for works to be presented at SCAR meetings that are related with the scope of our expert group. So that's it. Thank you very much.
Thank you. Thank you very much. Very, very interesting. Yes, now we have time for questions, if there are questions from the audience. I don't know if there is anything in the chat already, or you can just pick up, ask. While the people is thinking about questions, I have one about the marine records. For example, for the Cenozoic glacial ice sheet evolution, the one that you are now evaluating. Do you consider also, for example, deep sea drilling, ocean drilling? Because, for example, the first one, leg 28 in 1973, with the Glomar Challenger, it was the first deep sea drilling in Antarctica, on the Antarctic continental margin. And as far as I know, that was the time when the community actually realized that the Antarctic ice sheet was much older than Quaternary. So it's really, and it's still used as a very important, contains a very important information that is still used. For example, it's in the Ross Sea, but it's one of the most important sites. And there is an archive valve, which is preserved in the US in the IUDP repository. and the other half is used for sampling, for analysis. So I wonder if you could also include that into this geosite. Maybe you have done it already. I don't know if it's part of your list already.
I can speak to that one. That's a great question, and it's something we have talked about. You're absolutely right. There are some offshore drill cores and even a few onshore ones which are very worthy, and they certainly have geoheritage value. And the example you just spoke about is a particularly good one. You're right. That really was a game changer in terms of understanding the glacial history of Antarctica and realizing that the history of glaciation went back a lot earlier than thought, and that there had been many glacial and interglacial cycles. So it really changed our viewpoint of the climate history of Antarctica. So undoubtedly, these things have geoheritage value. The discussion we've had so far came back to the point that these drill cores are mostly already they're already well curated and conserved, I guess, in repositories around the world. And so there is already a very robust process in place for sampling those drill cores. Most have a working half and an archive half, and there is a process you have to go through to sample those. So in terms of conservation status, they don't need any more recognition. But certainly I think they have geoheritage status, and we should consider some of those drill cores and offshore records as Antarctic geosites, because they are so important for understanding the geological and climatic history of Antarctica. So far in the Cenozoic glacial history framework, we do not have any of those, but the one you mentioned, also perhaps the Andril core, for example, would be another one. I do remember working on the Syros core many years ago, and that one had not been archived particularly well, and the state of the core was not good. And in that case, that would have benefited from having a better curation process. So I don't have a specific answer, but yes, they have geoheritage value. I think they could be geosites, even though you can't actually go to it. You can access and see those cores in other repositories.
I see your point. Yeah.
I'd just add that the Marine Corps facilities are not listed on the sample repositories because we followed the guidelines that the action group established. It largely appeared to us that they were terrestrial samples that the action group put together and wrote their paper on. So this is a list of terrestrial samples and some dredges, but no actual marine cores or really cores of any type.
Okay. Any other question?
I have a comment rather than a question. As we've gone through this process, and when I have reached out to individuals who I think might have some good geosites to propose, I have found a little bit of resistance out there in the community, and I think it's based on a fear that if a particular site becomes a geosite, then it will automatically become difficult to access or sample in the future. And so we've put quite a bit of effort into saying that's not what we are about. We are trying to recognize sites that are important, that have geoheritage value, but we're not necessarily immediately trying to put geoconservation measures on there. We're not trying to make more red tape or more rules or turn things into an ASPA. that would be the exception rather than the rule. That would only happen if there was a very real vulnerability, a threat to the future of those sites. So I guess in some ways I was just trying to quell people's fears that this was going to get in the way of any future scientific research that they might want to carry out at a particular location. Many sites have been protected simply because they're very remote and people don't go there. And for many Antarctic sites, that will continue well on.
Oh, you are muted. If you're muted now, I don't know. I mean, at least to me, yeah. I don't know if it's only.
Yeah, I lost him too.
Okay.
We lost you, Cliff.
Okay, I won't repeat it all. I'm
Now
just
you're
saying
back.
there was
You're back. Yeah.
concern that this would prevent future scientific work, but that's not the intent. That putting conservation status on would be the exception rather than the rule, and only in those places where it really needs it.
Yeah, it may be good for a touristic reason. Some of them may be in regions that are more often visited by tourism. So it would be good to know that this is something that the scientific community care about and so needs to be protected.
Absolutely. And as I said before, most of these geological elements are finite, effectively finite, non-renewable things. Once they are destroyed effectively forever. So we don't get a second shot if something has been, pilfered by fossil collecting tourists or oversampled by scientists, or destroyed inadvertently while making, a base or something. So it's about being aware of these sites and being aware of their vulnerability.
Yeah. There is a question in the chat from Felipe. Felipe, would you like to ask or would you like us to read in the chat?
I am in the
in the rush.
So maybe better to read.
Okay. Cliff, can you read the chat?
Yeah, so in PUCON, yes, I remember having some great conversations with you. We talked about the geological context. Are there any updates? I'm not quite too sure I know what you mean there.
It's about the geological context that you define for the then create the geoheritage about the Antarctica. Specifically, we talk a lot about the glaciology part of the Antarctica that is not completely covered in those contexts. Like all the new, the newest context. I don't know if you can hear me well. Sorry.
Sorry, I'm struggling to hear you. There's background noise.
Yes. I was talking about the geological context that you create for the Antarctica Geoheritage selection. And we say that, for instance, all the glacial part of the Antarctica was submitted for the only one geological context. And I don't know if you have seen that an update for that geological context. For instance, other limits like the Permian Devonic or other contexts that could be related to Antarctica geological heritage?
I'm really sorry, I haven't cottoned on to what your question is.
I think it's related to the geology that exposes the retreat of the ice, or no?
I don't know. You can hear me better? Can you hear me?
Yes.
Oh, it's a lot of ground noise. Yeah, so my question goes in like, there is the geological context that you define for Antarctica geoheritage, and there was some context that were not included or were submitted to like a big part of one of the contexts. For instance, all the glacial part of the Antarctica wasn't very represented on the geological contexts. So I don't know if you have discussed that later or further.
I think I understand now. Yes, there are some elements of geoheritage that are difficult to put into any of our frameworks. For example, do we extend our criteria to purely glaciological features? Obviously, Antarctica has a lot of ice. It has many of the best examples of particular glaciological processes. In fact, in some places, perhaps even uniquely so. But that's quite difficult to capture. And of course, things are changing quite rapidly. And so we have struggled with the glacial Cenozoic framework. So where do we put some boundaries on it? Does our criteria extend to documenting occurrences of buried ice, for example, or sublimation tills, or particular types of glacial situation? We have one of our frameworks is a sort of a catch-all for things that don't fit nicely into any of the other frameworks. We haven't done anything with that yet, but I think that would be a place where anything that doesn't fit into those other frameworks that we've defined would be captured there. I think at the moment we've kicked that one down the road a little bit because it's a bit tricky. The more you think about these geological frameworks and geosites, the more there are that don't fit nice and neatly into our established framework. And I could think of other examples. Yeah, if ice was to retreat off previously covered areas, do those subglacial surfaces, would they potentially have geoheritage value and should become a geosite, even if they are transitory features? I'm rambling a little bit, and I perhaps haven't answered your question particularly well, but you are right that the context does shift the more you look into these particular frameworks that we've developed.
Are you planning to combine all of your geosites in a sort of publication for outreach, just to share it with the general public, because it's a really nice effort, and I think it would be worth to inform the general public about this. Because some of the geosites start to be popular, the low latitude. I mean, the one that we visit, the geopark more and more, and but so far nobody think about Antarctica in that way. So maybe it might be worth.
That's a good point, and perhaps Anne might have some comments here too. I'm not aware of any particular intent or effort to create any outreach about this. I mean, yes, many of these sites are interesting and they lend themselves to becoming geosites of general interest. And if I think about the New Zealand example where we've done similar work, we have a website that document geosites and provide instructions on how people can go and visit these places and what they're going to see there. And it's about raising awareness of these sites with the idea that people care about things that they know about. In Antarctica, where it is difficult to get to, many of these sites are protected by the fact that they are remote and very difficult to get to. And some would argue that raising awareness of these sites would be the worst thing that we could do. And perhaps the scientific community can acknowledge them, but we shouldn't advertise it beyond that. That would be true for many, but there are some sites where people are already going. And in that case, I perhaps would argue that educating people that are going there, tourists, for example, would be the way to protect those sites. Then people have an understanding and an awareness and a desire to protect those sites rather than damage them. It's a good concept.
Yeah, well, I didn't mean to stimulate, to actually visit the geosites, but to make aware that they exist. For example, I'm thinking about the Sirius Formation, from the place where you discovered that there was vegetation once, and now it's all covered by ice, so something which is capture the attention because it's really something different from what we generally see Antarctica, for example. Something really striking that it's worth to be shared with the general public.
Yeah, that's right. And I certainly use many sites, as I'm sure most of us do, but sites that will become geosites, I use those in my own teaching.
Yeah,
and would include those sites in any general outreach about Antarctica with the intent of raising interest and awareness of Antarctica in general. I think it's a good idea, and it has many parallels with the concept of ecotourism. So people don't necessarily need to visit a site, but becoming aware of the special sites, the amazing story that's told, people become interested and perhaps ambassadors for.
Yes, yeah. It's a good point.
Yeah, that's good. And
Yeah.
I see a comment in the chat here from Felipe saying perhaps it's a good idea to publish a book like the IUGS 100 Geosites. It's a fantastic idea. We are already planning to publish updates in the journal Antarctic Science, alerting the community to the geosites that we have established as we go through these frameworks. And that's an attempt to let the broader Antarctic, not just geo community, but broader Antarctic science community, or make them aware of the work that we're doing. And if they are planning field work to a particular place, they will at least know that actually this place has got geo-heritage values. So please consider that when you are developing your science plan. But I really do like the idea of a book. These sites are interesting. They are often quite visually spectacular as well. I think it would make a really nice book that would be of interest well beyond the science community, as you say, the general public. I think that would be a great goal for us further down the track.
Thank you. Any other question? Okay, so basically, if someone wants to be involved, just contact you, send you email, or participate, attend to your meetings. And in person, I think you meet for the Open Science Conference, as most of the action and expert group do, or maybe, I don't know, in a geological conference like ISAS or. But most of your work, I guess, is online, huh? Is probably sharing information and, yeah, evaluating these proposals. Okay. So I really thank you very much for this very nice, interesting presentation and for all your work that you constantly do. And yeah, I suggest everybody to attend the last webinar on December the 3rd. It's about the seismic data library, so I hope to see you there. And thank you again, the three of you.
Thank you.
Yeah,
Bye-bye.
thanks so much.
Bye.
Bye-bye.
Thanks, everyone.